This video we're looking at the extrema of a function. Now in calculus, we've made a lot of effort devoting time to determining the behavior of some function on some interval. Now, does f have a maximum value on this interval? Does it have a minimum value? Where is it increasing? Where is it decreasing? So in this chapter, what we're going to learn is how the derivative can be used to answer those questions. And we'll also see that these questions are really important in some real life applications, okay? So, definition of an extrema. So we're going to let f be defined on some interval containing c. All right, so f of c is the minimum of f on that interval when f of c is less than or equal to every f of x in the interval. So that means the y value associated with the x value c is less than every other y value. So it is the least value. It is the minimum, okay? F of c is the maximum if f of c is greater than or equal to f of x for all intervals. So the y associated with c is bigger than all of the other y's in the function. So the minimum and maximum of a function, we call these the extreme value or the extrema, okay? Now the extrema, if we're talking about this extreme value, right? This, well, not just the extreme value, but the absolute, okay? So these minimums and maximums of the function, we're calling the absolute minimum and the absolute maximum. Sometimes you hear it referred to as global. Now, the extrema can occur at interior points, or they could occur on the endpoints of an interval, because remember, we're talking about an interval. So if it does occur at an endpoint, we call that an endpoint extrema, okay? Now, a function doesn't have to have a minimum or a maximum on an interval. So let's look at a couple of figures here. If you look in figure 3.1a, we can see here that there is a minimum, there definitely is a smallest point, and there is a maximum. There definitely is a maximum value. And that's because the interval is closed. We're talking about the closed interval from -1 to 2. If we leave this as an open interval, then notice here, this is never getting to that value. It's going closer and closer and closer, but it's always moving closer and never hitting it. So it never actually achieves a maximum value. Now, notice over here, well, this is going up, so we ignore this side over here. Still, it has a minimum, but it does not have a maximum. Check out 3.1c. Here, notice we have an open hole here. So continuity, or the lack thereof, can affect the existence of an extrema as well. So notice, because it's never reaching that smallest point, can never get lower than lower than lower, there's no minimum on this interval. So we have the extreme value theorem. What it says is that if f is continuous on a closed interval, then f has to have both a minimum and a maximum. But it is a requirement that it be continuous and a closed interval. So this is the definition of extrema. If you have any questions about these, just shoot me a reminder or ask questions in class.